Welcome back. In this episode, I'm going to add some basic ship movement so we can move the ship around before we get into adding the physics and some basic collision detecting. So the first thing we want to do is when the player moves, we want to start moving the ship to that location. So what I'm going to do is up where I added the sprite, I'm just going to say this dot, we can call it player, I guess, equals, and then I'll just say the ship, or actually let's just call it ship since it'll be the only ship on the screen. So right now we're just printing out the X and the Y, but let's do a few other things here. So one thing I'll do is I'm going to split my screen. I'm just going to go, I'll save this real quick. I'm going to go into the constants and I'll say export const, it's just constant. Oops, constants works. And let's just make one that's called ship speed. And for now it's going to be 5, and this will make a little more sense in a second. So I'm going to go back to the game screen, and up here on top of scenes, I'm going to import constants, which is a little confusing since we already have constants, and what we want to do is first I want to calculate the difference between where the touch event is happening and where the ship's XY is. So I'm going to add a const here and I'm going to say diff x, and I'm going to say that's going to be the pointer.x minus ship.x, and I'm going to deconstruct the ship out of this. I'm going to do the same thing for y. And then the next thing that I'm going to do is I'm going to, actually I'll do that after so that it makes more sense while I'm doing it. So the next thing I'll do is I'll just say const direction, so direction equals new phasor dot math dot vector 2, and what I'm going to pass in here is diff x and diff y. And the next thing I'm going to do is I'm going to call normalize on this, and what this will do is it's basically going to make it so that whatever the largest value is 1 and the other one's a fraction of that. So if it was a y of 5 and an x of 10, x would become 1 and y would become 0.5. And then what I want to do is I want to say ship.x plus equal direction.x times constants dot speed, ship speed. I'm going to copy this. I'll just make these all y now. Okay, so this is enough to get us started, so I'll show you what happens now. It should move towards my mouse if I make a mistake, but it jumps around like crazy when it gets there because it's always adjusting by our speed, which is never quite the right amount to get to the mouse. So what I'll do here is before I calculate the direction, I'll add an if statement in here, and I'm going to check whether or not the difference between the x and the y is less than the speed. So what I'll say is math abs. So I'm going to take the absolute value here of the x, and I'm going to say that this is less than constants dot ship speed, and math dot abs again. So take the absolute value of this time diff y. If it's less than constants dot ship speed. In this case, we're going to handle it differently. And then we'll say else. Perfect. All right, so here, what we want to do is say that the ship.x equals the pointer.x in this case. And ship.y equals pointer. Okay, so now basically what can happen is when we click or press somewhere else, it'll follow it. And then when it gets to wherever the pointer is, it just, oops, there's a mistake in my typo there. All right, so it just follows the cursor basically. Pretty cleanly now, I think. All right, so now we have our basic movement. So in the next video, we're gonna dig into arcade physics, which is something very unfamiliar to me because I'm used to making RPGs, which usually don't use a physics engine. So it should be a little bit of an adventure. All right, see you in the next video.